Hi everyone. Here my plan is to cover section 1.3 that we started last day, and we discussed a few things here. This section is all about experiments and social studies. So last day we talked about associations and causations. Okay, right, associations and causations. Then I gave you an idea about confounding variables, and also we discussed observational studies as well as experiments. I just gave you the definition of these experiments, and today we are going to, through this video, I'm going to talk about experiments a little bit further, and also randomized experiments. All right, so I'll skip the skip some pages that we discussed last day. So it's specifically, if I recap what we have done last day, we talked about associations. If two variables are if two variables they have weak relationship, we called associations. They have association. On the other hand, if two variables, if they have a strong relationship, then we call they have causation, or they are causally associated. Based on the example we discussed, I think it's clear for you guys to understand what is the difference between causation and association. So I'll skip those examples now. Then if you remember, I talked about the confounding variable, which is about the third variable. Let me write it down here. So if we have two variables that they have a relationship, and there's another variable who can affect to both of these, we call confounding variable. Okay, so the definition of the confounding variable is a third variable which can associated with both x and y variables. We call that confounding variable. So whenever confounding variable occurs, then we cannot determine the causation. Okay, so we don't have causation, just associations. Then we talk about the major point in this 1.3 section, which is experiments and observational study, or simply we call OBS studies for this one. I told you observational study is all about working with existing data. You have data, you use it. That's it. So we call it observational study. Almost all the time in statistics, we do this. We use this kind of studies. Unlike these experiments, in experiments, researcher has the capability to control one or more explanatory variables. So whenever researcher collect data by controlling one or more explanatory variables, and that point we call that study is an experiment. Okay, so at the same time I mentioned, based on our association and association and causation, observational studies, we don't use to make conclusion. We never make conclusions using observational study. On the other hand, using experiment, we make conclusions. The reason is, in observational studies we have associations. We have associations only, and almost all the time. And in experiment we have causation, or the variables are causally associated. Causally associated. Okay. All right, that's the reason. uh, so yeah, I have mentioned it here, right here. Observational studies can almost never be used to establish causation. So causation, I showed you the last day I showed you the relationship. Causation causation can imply, this means imply, can imply, causation can imply association, but this side doesn't work. Association doesn't imply causation. Okay, remember that one. Next, randomization, which is the way the confounding variable issue. Whenever we have a third variable that affect to x and y variable, for example z here, so we cannot eliminate the effect 100%. However, we can reduce the effect. What we can do is we can randomize. Okay, we can randomize, we can use a random process to reduce the effect from this third variable. That's actually what we do. So randomly assigned values for the exploratory variable can let me change the color, can help us to reduce the effect from this third variable. So what we do is simply we randomly assign here, for example, we randomly assign x values, different x values, x equals 0, x equal 10, x equal 11, x equal, let's say 285, something like that. We simply randomly assign x values and get the corresponding y values, so that we can reduce the effect from this third variable. Okay, that's the one technique we use. So we use that randomization technique in our experiments. So in these experiments, although the researcher control one or more variables when they collect data, we randomize these experiments. So these in this exploratory variable, for each unit, you know what is this unit? Unit mean each row. Okay, unit mean each row. When we collect the data across different variables, we consider randomly before we get the responses. That's how we randomize these experiments. So we can avoid, or simply we call reduce, the effect from the confounding variable. So in experiments, actually the setup of this experiment is very interesting. So when we talk about experiments, let me draw a picture here. We have two groups. In experiments, at least we have two groups. This first group we call treatment group. This group is treatment group. And the other group is a reference group. So we call that a placebo group. The difference between these two groups are the treatment group, we give the actual treatment, or we treat it. We give the, for example, if we are testing a drug, this is the treatment group, is the group we provide the actual treatment. But the placebo group, we don't give the actual group, because in reality, when we need to compare something, we need to, at least we need to have two things. Okay, something we change, the other thing it did not change, so that we can compare. So that's the purpose here. That's why we use placebo. The group do not treat. So the treatment group has different exploratory variables, the exploratory variable values, and then if we need, we can divide this treatment group further groups, subgroups. If we want, we can divide it into subgroups. It depends on the experiment that you are dealing with, but idea here is you have treatment group and a placebo group. The treatments randomly assigned. So we are talking about randomized experiments. So in normally experiments, we have two groups: treatment group and placebo group. I'll talk about placebo group a bit further in next couple of slides. Um, if you need to randomize this experiment, that means to avoid the confounding variable issue, we randomize it. So what we can do is simply we can divide this treatment group further and randomly assign exploratory variable values to different groups. Then we have, as I mentioned, another the other group, treatment group, and the other group. Normally, we in general we call control group. And next slide, I'll show you the group, that control group we call the placebo, because we give them a placebo. Okay, right. So when we doing actual experiment, we treat to the treatment group, and the other group we keep it to compare. Okay. So however, if for example we are testing a drug, we have two groups. We give drug to actual drug to one group called the treatment group, but the other group, the control group, we don't do anything. So at that time there may be a problem, because people in this control group may think they don't get anything. So that might affect to the experiment. So we call that is a mental effect. To avoid that mental effect, we give them something similar to the drug, but it is not the actual drug. That's the placebo. So this is what I was talking about. So the placebo effect happens most of the time based on actually based on the past research. Studies estimated that about 75% placebo effect occurred in different experiments. So we have actually normally we call placebo group, but the two groups, treatment group and the control group, and this control group we give them a placebo. So you can call it placebo group as well. Right. So we can avoid issues like mental effect, comparing purposes. We can come up with the idea of placebo group, and also we randomize it, as you saw earlier. We randomize it to avoid the third variable issue, and we can go further and we can do this double blinded. That means we randomly assign explanatory variable values, and also we can randomize this experiment in two different two level blindfolded. Like researcher doesn't know, researchers select uh, the people or the objects randomly. Even the patients doesn't know which group they are belong to, and also the researcher doesn't know which group he assigned patients, something like that. So two layers of randomization. So we call that double blinded. As I mean, if possible, we can go for this double blinded or double folded this randomization as well. But sometimes we have some limitations that I'll discuss in the next slide. We cannot make it in practice. However, the control group in the control group, we give a placebo so that we believe we can avoid that mental effect, so it will not affect to the experiment. It's actually a fake treatment. All right. So here, as I mentioned, we can most of the time we try to do randomization as much as possible. However, we have problems, we have some practical issues. They are ideal, but sometimes they are not ethical, or simply it's not possible. Best way to most of the time in statistics, in this course almost all the time, best way to collect data is observational study. We consider observational study almost all the time in this course. Right. So randomization versus random sample. Actually, there is a difference between that. Doing a randomized experiment on a random sample, it is ideal, but it is really hard. So again, we select a random sample and then randomize experiment on top of that sample by using that sample. So there are few layers of randomization appears in that particular experiment. So it is really good if we can do it, but most of the time it is hard. uh, so if possible, at least try to use random sample or randomized experiment, then we can get good results. So in experiments, our focus is to establish causations so that we can make uh, summarize, or we can make a conclusion about its population. That's the purpose. Especially most of the time we talked about this drug testings. So in summary, here we talked about association, causation, and also OPSI studies and experiments. How randomization involved in this experiment, and also control group, which is the group we give placebo. So sometimes we call it a placebo group as well, and the placebo effect. So that's it about the section 1.3. There are no actually problems that we need to solve using this part, but you should get the idea. That's all you need. You must have the idea about these experiments. All right. See you next time. Thank you.